Good day to you. This is teacher Leland, Alejandro, and we're going to discuss parallel and perpendicular lines. These are lecture examples, and we're going to see the problem set after a little while. Let's check on the other screen. Okay, here's the problem set, and this is under parallel and perpendicular lines lecture examples. So let us see the title first. Okay, over here. So parallel and perpendicular lines lecture examples. Now, what we're going to have here is more on perpendicular lines. Okay, the other part has been discussed already under parallel lines, but this will actually be the continuation, which contains more of the perpendiculars. All right, let us start with the first number. Solve the following. We're going to see the figure, and you can see here like a triangle. But observe first the setup, okay? You have a line segment AB and being bisected by a line L, okay? This is actually line L there. Okay, so this particular line, which can also be called line CD, and you can see the segment AB being divided by this line at right angles, okay? This is divided into two parts equally because of these marks there. That means AD is equal to BD, okay? Because of that symbol, we can easily answer the question, what is the length of AD? Okay, one part is given 13, and that means the other side is also 13. Because of the marks, that means they are congruent. And without showing any computation here, this is just by inspection, AD is equal to dB. And it's because dB is given 13, then we can easily conclude that AD is also 13 units. Okay, that answers our first question. Let's continue with the next. All right, let's have the next. We'll just scroll downwards. All right, here's number 2. Okay, here's number 2. And this is the figure. It's quite similar to the first figure. What line segment has the same measure as RS? Okay, where is RS first? RS is over here. All right, there. Okay, I marked it with a red line segment there. There is RS. Okay, what line segment has the same measure as RS? First, we observed the given figure. Okay, we have here another perpendicular bisector which divides RT. Okay, it actually divided RT here because of this mark and this mark, and that means they are equal. That means RW is equal to WT. Okay. Also, this is a right angle. That means line N is a perpendicular bisector. And there's a theorem about perpendicular bisector. If a point lies on the perpendicular bisector of a segment, then that point is equidistant to the endpoints of the segment. Okay. All right. So again, if a point lies on the perpendicular bisector of a segment, then the point is equidistant from the endpoints of the segment. So it is very clear in this figure. Okay, we can consider the point S. Okay, let's exaggerate the point S there. That point S lies on the line M, which is the perpendicular bisector. Okay, so if a point lies on the perpendicular bisector of segment RT, then point S is equidistant to R and equidistant to T. Okay, that means this is equal to this. And so what line segment has the same measure as RS? It must be TS. The answer here is TS. Okay, same measure. Okay, they are congruent. All right, so this is the answer. All right, so this goes to our number 2. Let's continue with the next number. Let me just clear it and scroll down. Okay, here's the third. Okay, we have another figure, and observe the figure. We have the corners R, point T, point S, point Q of the quadrilateral, and observe what type of quadrilateral is this. We haven't discussed quadrilaterals yet, but this is actually a kite, okay? And we can see a line M dividing the figure into 2 equal parts. And we can see a segment ST, okay? A segment ST, which is divided by the perpendicular bisector. It is a perpendicular bisector because the line and the segment, okay, intersect at right angles, okay? So that means this is a perpendicular bisector. This particular line, okay, is a perpendicular bisector of the segment ST. Okay, it's a perpendicular bisector of ST. And the question here is, which line segment has the same measure as QT? Okay, all right, here's the question. Which line has the same measure as QT? Which line segment has the same measure as QT? There is QT. We marked it with another red. Okay, there. Okay, we can actually make use of point Q. Okay, we can make use of point Q. There. And since we know that line M, okay, is a perpendicular bisector of line segment ST, okay, it's a perpendicular bisector, and we have this particular theorem. If a point lies on the perpendicular bisector of a segment, then that point is equidistant to the endpoints of the segment, okay? And that means we can conclude that QT is equal to QS there, because the endpoints are point T and point S, okay? Those are the endpoints. And line M is a perpendicular bisector of segment ST. Therefore, we have the answer, okay? Which line segment has the same measure as QT? The answer is QS. There, this will be the answer. And we can mark it like that, okay? Because segments has this particular symbol there, okay? Which line segment has the same measure as QT? Then it's the other segment, which is QS. That answers our number 3. Let's continue with the next. All right. Let's continue with the 4th. Okay, here is number 4. All right, here's the figure. Here's the question. The length of the segment BD is 37. Okay, so we have a numerical value here. And this is BD. This is given 37. All right, let's continue reading. What is the length of CD? All right, we're asked to find this length. There, I marked it red, okay? What is the length of CD? All right, how are we going to approach the problem? First, we observe the given. Here's a diagram, and here's a 90 degrees here. That means line M, this line here, okay, divides the segment AD. Okay, this is AD. and it's divided into two equal parts. Okay, that means line M is a perpendicular bisector. Okay, and that means we can use the theorem. Okay, if a point lies on the perpendicular bisector, that happens to be this point, okay, also this point, okay, all right, and line M is a perpendicular bisector of segment AD, okay, AD. Therefore, if a point lies on the perpendicular bisector of a line segment, okay, then that point is equidistant from the endpoints of the segment AD. Therefore, we can conclude this is equal to this there. And this segment is equal to this segment there. Okay. In other words, we can write AB equal to BD there. Okay. And we can have the equation. AB is 3x minus 2. And BD is 37. And therefore, we can solve for x. Okay, let us solve for x. We add 2 and we add 2 to both sides of the equation. Right side becomes 39. And the left side is just 3x. After division by 3, we have the value of x at 13. There. Okay, we also have some conclusion. All right, we have AC equal to CD. There. Okay, and we have the equation. All right, 5x minus 1. That's AC. And we're after CD. There. Okay, and so we have the value of x, that's 13. So we have 5 times 13 minus 1, it's the CD. And we have 65 minus 1, it's CD, and CD is 64 units. Properly written, CD equals 64 units. There. All right, so we have the answer. All right, that will be for our number 4. So just remember the theorem. If a point lies on the perpendicular bisector of a segment, then that point is equidistant to the endpoints of the segment. All right, so that would be for our number 4. We continue with the next. Let's have number 5. Okay, let me just scroll it and see the next problem. It's over here. Number 5, the length of PT in the figure below is 12 meters. So this is PT. There. The one with the red line segment, okay? This is 12 meters. All right, 12 meters. Okay, now observe the figure. We have a line X, which is a perpendicular bisector of segment ST, okay? That means we have a line X, okay? Line X is perpendicular to ST segment there, okay? All right, so the line X divides ST into two equal parts at right angles, okay? You can see the marks here. That means 90, and marks, that means ST is divided into two equal segments. And so, if a point lies on the perpendicular bisector of a segment, then the point is equidistant to the endpoints, okay? And that must be point P and point R, okay? Those points are equidistant to the points S and T, okay? All right? because point R and point P are on the perpendicular bisector, which is line X. And so we can conclude here, all right, PT must be equal to SP. There. Also, going to the upper portion, all right, SR is equal to RT. There. Those are the parts that we can actually mark. But what is asked here is, what is the length of ST? Okay, and ST is just the line segment. Okay, all right. So all we need to do is compute half of that, and we're going to double it. Okay, all right. So we shall make use of the equation PT. PT is equal to PS. There. Okay, from the drawing, you can find this in the drawing. PT is 12 and PS is 5x minus 3. 5x minus 3. There. All right, let's solve for x first. This will be adding 3 to both sides. We add 3. So the left side is 15 and the right side is just 5x. And so we continue by division. We divide both sides by 5. And we will have x equal to 3. Properly written, x equals 3. There. All right. We will not stop at x. We are not supposed to stop there. We're supposed to find the length of ST. Okay. You see, one part of ST is given 3x minus 1. That's one part, which is equal to the other half. Now, if you will only double this, 2 times 3x plus 1, okay, you can see that over here. There. I encircled it in the diagram. 2 times of that will be the total ST. So there, okay? All right, so we will just have to substitute the 3. That's the value of x here. And this will now be computed 2 times the quantity, 3 times 3 plus 1. And so the inside of the grouping symbol parentheses, we will have 9 plus 1. And this continues 2 times 10. And ST happens to be 20 meters. There. Okay, that's the answer, 20 meters. All right, so that gives us the solution for number 5. We're now going to continue with the next number. We shall continue with number 6. All right, let's clear the screen and scroll. Okay, this will now be for number 6. Here's number 6. Okay, in the figure below, BD equals 19 units. Okay, that part is over here. BD. There. We marked it with a red colored line segment. Okay, we can also see the other markings. This means 90, and so the line L, this line, okay, that line is a perpendicular bisector. It divides AB at right angles and into 2 equal parts. So this and this. And we can have AD. AD segment is congruent, all right, congruent to segment BD. There, okay? All right, and that means they have equal measurements. And we can make use of this to set up an equation. We have 4x plus 3, and this will be equal to 19. There. And so we will solve this simple linear equation to get x. So by way of subtraction, minus 3 to both sides, this will now be 16 equal to 4x. And so after division by 4 to each side, x is found with a value 4 there. All right. Now we can make use of the theorem, okay? Because we have a line L as perpendicular bisector of segment AB. Therefore, if a point lies on the perpendicular bisector, and we can consider a point C here, all right? If a point lies on the perpendicular bisector of a segment AB, then that point is equidistant to the endpoints of the segment, okay? That means we can conclude CB is equal to AC there, okay? And so we can make use of an equation CB. The CB segment must be congruent to AC segment there. And that means CB distance is equal in measurement with AC distance. And so CB can now be equated to the expression for AC, which is 7x minus 2. And this will be evaluated using the x that we have. X is 4. 7 times 4 minus 2. This is 28 minus 2. And we have the answer at 26 units. There. And that answers the question. What is the length of CB? CB is 26. There. All right. That will be for number 6. We shall continue with number 7. Let's clear the screen and continue scrolling to the next number. All right, number 7 now. Here is number 7 and the other screen, other part of the document. All right, here's number 7. In the figure below, RT, okay, this is a segment RT. All right, RT measures 25, okay, and the 25 is already marked in the drawing. We can also see other parts of the drawing with the markings of right angles and this segment equal to this segment, okay? And so we can conclude that the line M is at right angles with segment ST, okay? And it divides the segment into 2 equal parts. Therefore, line M is a perpendicular bisector, okay? Perpendicular bisector of ST. And so if a point lies on the perpendicular bisector, okay, and that is point Q, all right, then that point Q is equidistant to the endpoints of the segment. And therefore, point Q is equidistant to point T and point S there. All right, so that means SQ is equal to QT there. And we can have that particular equation. And this will be SQ equal to QT there. And therefore, we have the equation SQ equal to QT, which is equivalent to 4x plus 3 there. Now, we don't have the x yet, but we can get that from the segment ST because RT is equal to SR there. And we have RT at 25. We have SR in algebraic expression 3x plus 7 there. Okay, so we can get the x from the left equation first, and then we will use the SQ later. All right, let us solve for x first. Okay, using this 25 equals to 3x plus 7, subtract 7. And the left side is 18. 25 minus 7 is 18. The right side is 3x. Okay, we have 18 equals 3x. We divide by 3. We have x equal to 6. There. Okay, we now have the value of x. It's 6. We can now proceed to SQ at the at the right side. All right. So this is now 4x plus 3. This means 4 times 6 plus 3. And this is now 24 plus 3, which gives us 27 units. Okay. So this is 27 units. This is SQ. There. That gives us the answer for number 7. Okay. And the solution is on the screen. All right. We'll continue with the next number 8. Let's continue with the number 8. All right. Okay, let's scroll. And here's number 8. Okay. In the figure below, line V is perpendicular bisector of WY. All right. So our segment is WY. Okay. Over here. That's our segment. Okay. That is divided into 2 equal parts by this line. Okay. All right. And so line V is a perpendicular bisector. Again, if a point lies on the perpendicular bisector, in this case it's X, okay? If a point lies on the perpendicular bisector of a segment, then that point is equidistant from the endpoints, okay, of the segment. So that means these are the endpoints Y and W, and point X is on the perpendicular bisector. We conclude this equal to this there. And so we can actually solve the required. Okay, we're after the length of WY actually. All right, we're actually after that length. All right, so we can make use of WX first. WX is equal to XY. There. Since point X is on the perpendicular bisector, then we conclude point X is equidistant to the endpoints, W and Y. And so we have the equation WX is equal to XY. And so the expressions there will be 5x minus 4 equals XY. That happens to be 3x plus 16. We will solve for X first. Okay. All right. We subtract 3x first, the smaller x term. We get something at the left like 2x minus 4. The right side is just now 16. Okay, now we isolate the x here by adding 4 to both sides. Add 4 and add 4. We get a 20 at the right. Left side is now 2x. Okay, after division by 2, we get some value. All right, we divide by 2. And we divide by 2, x is found. 10. There. Okay. Now we can proceed to WY. Okay. We're after WY. The length of WY. Now, how do you get the length of WY? All right. One part, WZ, is equal to the other part, ZY. Okay. As seen with the marks over there. Okay. All right. That means we have 2 times of WZ is equal to the total. Okay. 2 times of that. So that means we can set up the equation, the total WY is 2 times WZ. There. Okay. Because WZ and the other half, they are equal. So we'll just double one of them. All right. And so WY is equal to 2 times WZ, which happens to be in the expression 2x plus 4. And so we can now use our x. 2x means 2 times 10. plus 4, and that will be the numerical value inside the parentheses. This will now be 20 plus 4, and this gives us 2 times 24, and this is now 48 units. There. Okay, so this is our WY, and this gives us the answer there. And so we completed all our 8 examples. I hope you were able to learn from these examples and use it in your activities. And we're going to discuss more later. This will be all for now. Goodbye.